Alright, ladies and gentlemen, I am here with a different bread maker. Yeah, funny story, that bread maker that I dug out of the dumpster and was going to tear apart on video, not only did that end up working perfectly, but we baked a loaf of bread in it and it was delicious. And Mom was like, hey, I'd like a new bread maker. And I thought about it and I'm like, yeah, okay. So in return, I get our old bread maker. This is a West Bend automatic bread and dough maker from the early 1990s. I've known this thing for most of my life. We acquired it from a friend of one of my sisters back around 1998 or 99, and we've used it off and on ever since then. We've never been ones to make homemade bread, but we did it once in a while. This thing came with the book and everything, and as a matter of fact, the original owners in the book actually recorded when they had replacement parts done on it. I think it was 1995, they replaced this bread basket here, and then they had to replace another part on it in 1998, but I forget what that was. This has been a fine and dandy bread maker. West Bend, they're still around. I don't know if they're a real company still that makes their own stuff, or if they're just a name that gets stuck on nameless Chinese stuff now. I don't know. But you guys probably know I'm not one to destroy vintage stuff. But I thought about it for this particular bread maker, and I've decided to give it the axe, and I'll show you why right now. Yeah, that's not supposed to happen. The hinge there, you can see it's got that little tab there. It's missing on this side, and the door, as a result, does not like to stay on. So we are going to tear this thing apart and see what's inside it. Kind of interested to see what's inside here. I think there will be a few cool things that I might be able to play around with or use for projects. I'll take a stab at what we should find in here. I always like to guess what I'll find inside electronic and electrical appliances and stuff. I'm guessing that there will be a single small circuit board that covers all the electronicry mounted behind this panel, no doubt. On that board there will probably be a single integrated circuit to handle all the electronic jobs, perhaps a ROM chip where the bread programs are stored. This thing only has well, it doesn't really have programs, but you can choose the color and the type of bread and stuff, so there might be a ROM chip to handle that. Maybe a memory chip to store the current program in. Or perhaps it's just one single large IC that handles all those functions, one big custom IC, but we'll see. Obviously there will be a motor. I've been trying to think, what kind of a motor would a bread maker use? Surely not a shaded pole motor, because they're not powerful enough for something like this. I don't think an induction motor, because that'd be probably too expensive for something like this. I've been thinking my biggest guess it would be a universal motor, but I'm not sure still, because this thing, as well as the other bread maker, aren't particularly loud, and all the universal motors I've ever seen are generally quite loud, but maybe not. I have seen a few quieter ones before, so perhaps a universal motor, that'll be my guess. And also, I'm thinking perhaps, maybe hopefully, since that'd be cool to toy around with, hopefully perhaps a power transformer inside here that would provide the low voltage power for the electronics. So maybe we'll find that as well. Anyway, let's find out for ourselves. So I'll just haul the basket out here. We don't need to dig into that anymore. Oh, a heating element, of course. That might be fun to play around with. Put low voltage to it, and I don't know, it gets warm. And yeah, obviously a gearing system there. So that might be interesting if it's a single gearbox. Alright, let's see how this hauls apart. I see screws right there. So what I'm going to do is, I'm going to grab my screwdriver and take these screws out. There's 4 here, and see what we get. Alright, I got the screws off. Let's, quite a bit of rust falling onto my bed there, oh well. Let's see what we have here. I think there's just... Huh, that's interesting. Obviously this is the gearing mechanism, and holy crap, that is a shaded pole motor. Wow, that would have been my last guess for something like this. I figured a shaded pole motor wouldn't have enough power for something like this. But that's definitely a shaded pole motor. That looks just like one you'd find on a box fan. Oh, that's really cool. Alright, let's see, where do we go from here? How do I get this top? Oh, there's screws here, so I'll take those out and see what we get there. Alright, I took the screws out of this, couldn't really budge it out. I found one screw here, so I think maybe this thing can come off. That's the ticket, I guess. Okay. Well, no, we got a transformer. Not as big of a one as I would have expected to find, but big enough to do the job. A lot of resistors. You got a buzzer. It should be an IC somewhere. Oh, look at that. Nice big relay that would control the motor and or the heating element. Perhaps this transistor controls the motor and the relay controls the heating element. Oh, there's the data manufacturer, 1993, West Bend Company. And what's this? There's this transformer. What's this transformer say? Output 9.4 volts AC. Huh, that'd be quite useful. Very good. Oh, we have a connector here I can pull out. And we have spade connectors there. Those would go to the motor and maybe to the heating element. Yeah. I'm very surprised that there's no IC on here. Maybe it's on the other side. Who made the transformer? Does it say? It says motor. I guess that's the company called Motor. Yeah, that'll be cool to experiment with. And a nice big buzzer. What kind of transistor we got on there? Let me bend this capacitor back. MAC 2211, not one I'm familiar with. And this really nice relay here. What's the relay say? 12 amps, 120 volts AC, or 28 volts DC. That's the ratings it's for. Although it also says 9 volts DC, so I'll have to look it up. I'm not familiar with how relays are rated. 275 ohms, that would be the coil in resistance. And that DT there perhaps means double throw. But there you go, we'll dig more into that later. Now, we've got this here. Oh, we've got two nuts there. I'll grab some pliers and screw them out. Two there as well. Alright, nuts are out. I think this can pull off or bend off. I'll bend it. And let's see. Yeah, that's oh look, it's even got fan blades on it. Yeah, that is definitely a fan motor. That's the exact same type of motor you would find on a box fan. Exactly the same type. It's a shaded pole motor. A large shaded pole motor. So this would have enough power to run something like this. So yeah, really, I guess that's all to see in here. So what I'll do right now is I'll try and dig that motor out. And I'll dig the heating element out as well. Alright, I got everything out, which I regret doing on my bed now because this thing was a lot filthier than I thought it would be. But I can clean that up. That's the stand that the motor and the actuator sit on. And here's the motor itself. This motor is still is really lubricated, which you would expect for something lightly used like a bread maker, especially one which was rarely used like this one was. It's actually a West Bend motor, according to the plate on it. It was actually made by West Bend, which is quite cool. I expected this to be a General Electric or perhaps a Westinghouse motor. There's the model number, 120 volts, 60 hertz, 2.3 amps, 1/20th of a horsepower, and 1050 RPM, thermally protected, and yeah. Oh, it's got a date on here. November 94. So this bread maker was made around 94 or 95. But single speed motor, it's got 2 wires coming out of it. And what we can do is actually, I'll do right now, let's connect this thing up to power and see how it runs. Alright, got the motor just set on the plate here, not connected to this thingy. I got it wired up. Let's see how it works. Nice and quiet. How's that fan move? Oh, it moves it the other way. Motor's quite vibraty. Oh. I need my kilowatt meter. Alrighty, let's go again. 2.3 amps, just what it said it would do. Wow, a lot of power. Their power factor. Nice and quiet when you get off the floor. Well, this seems to work well enough. Maybe just for fun. Let's connect it back up to the actuator and see how it works. Alright, let's try it now. I bet it'll be a bit louder. Oh, not really. No, I never expected a fan motor would be used in a bread maker. Now imagine this, if it turns out that the gear wheels on these two things are interchangeable, we could switch them, and then the motor would drive this part at very high speed. That would be quite interesting. I almost forgot, this also fell out of the bread maker, a Canadian dime from the year 2000. Wonder how long that's been there. And here's the circuit board. Little transformer there. I did some thinking, and I'm not sure if a transformer can actually work this way. I probably can find out if I Google quick enough. But I wonder if you were to hook this transformer up in reverse. So if you were to put 120 volts through the 9.4 volt side, if you'd get some 1500 volts out of the input side. Theoretically it should work this way, but I don't know if there'd be problems with arcing or whatever. Regardless, I'll never try it, or at least I won't try it anytime soon, because I don't have the knowledge to safely work with high voltage stuff like that. And here we have this nice relay. I'll definitely desolder that, and perhaps use it in some sort of project somehow. I always think of these projects, but of course I hardly ever follow through. And of course the piezo beeper, and all that stuff you've already seen. On the other side, the LCD display, and I did find an IC. So there's the numbers on it. I haven't looked them up yet, but I would bet this is a custom IC, or at least custom as in it was specifically for bread makers. It's not a general purpose thing. And there's all the micro switches and the power LED, and there you go. And I see 4 diodes here labeled D1 through D4. They probably form a rectifier to change the 9.4 volts AC into DC to run all the electronics. Here's the circuit board again. As you can see, I already removed the buzzer, which as you can see, it had 3 contacts on it, 2 there, and whoops, and 1 on the left here. And I wasn't aware of that until I tried desoldering it, and I desoldered those 2 holes and it wouldn't budge, so I yanked on it until this contact ripped out of it. I've never seen a piezo buzzer with 3 contacts on it, so I'm wondering what that could have been for. But I've already removed it. I also desoldered the primary legs of the transformer, so I could take those and wire them up to power, which you can see I have done here, and I put a fuse in line just in case something went awry. But if we can actually plug this into power, You can see the relay does a quick self-test there. It acts normally. It doesn't give any error. It goes right into the mode where you can program a type of bread to make. And for anyone who's curious, there's the electrical specs. So there you go. And weird thing is though, if I press the start button, which is right here, so it actually tries to operate, it says too cold. There, it goes back into the programming mode. It says too cold because this had a feature. It would say either too cold or too hot if the bread pan was one of those things. It had a temperature sensor, I believe is this thing. It had a temperature sensor on it for that reason, and if the bread pan was too cold or too hot, that would of course interfere with the proper formation of the bread, and so it would cut off until you move the bread maker into some place with a normal temperature. But this is giving the too cold error, I assume, because that temperature sensor is not connected. So it's just reading it as being as low as it can go, so it won't work. But we can press buttons there, select different types of bread, and it otherwise functions normally. It's not complaining because it's not connected to any of its other components. Just says it's too cold. So all I'm going to take off here, I'm going to take off that transformer, take off that relay, and I might take off this big transistor, which I can't figure out what it is. The numbers on it is MAC2211. I've looked it up and I don't come up with anything. If I Google just 2211 transistor, I get a transistor, but I don't think it's the right type. So if anyone might know what actually this is, it might not even be a transistor, it might be a voltage regulator or something. I'd appreciate any knowledge. And that's about it. And finally, here's the original instruction book, falling apart but still intact. Mom has decided she's going to keep this book since it has recipes for all sorts of bread and dough. And unlike the manual for the new bread maker, this manual doesn't have mistakes in those recipes. But oh, apparently something Mom printed out a long time ago. Cheddar cheese bread. Yeah, I remember that. That was good. But if we look at the very last page, the original owner, I guess maybe the last English page, right here, it turns out, from what I can tell here, they actually only replaced one part, but here's the replacement parts you could get at the time. And I guess in November of 1995, the original owner just decided to price replacement parts in case they ever needed them. And then they wrote something here in April of 1996. I don't know what they wrote. I think 5 to 7 something, maybe 5 to 7% up. So maybe those prices went up in 1996. And then here it says new pan, which they paid $30.95 for on October 5th, 1998. So pretty nice that a bread maker from 1994, you could still buy replacement parts for it in 1998, almost 1999. So there you go. And the last thing we're going to look at is this heating element here, which I'll do for now, just for interest's sake, is I'll measure the resistance of it. And there's your law. So what I'll do right now is, I'll keep that out. Hopefully I can use that for something cool sometime. What I've been thinking, see, Mom has a box fan, and the motor on it's just about done. I wonder if that motor would fit that box fan, and if the hub would fit the blade set. If so, that would be interesting to replace the motor on that box fan. But knowing Mom, she'll probably just decide just throw away the box fan anyway. But I will take a look at the very least. So what I'm going to do here is, you might not expect this, but after I get all the wiring off everything, I want to save all the wiring. What I'm going to do is, you might not expect it, I'm going to put this thing back together, all except for the parts I want to keep. And the reason I'm going to do that, you will see in a future video, and it will be fun. So, I hope you guys enjoyed this little teardown. Maybe I can do something cool with the parts I have now. And thanks for hanging out with me, and I'll see you guys later.